We didn't always know what the atom looked like. Even today, we're not entirely sure, but we have a far better idea than ever before. In this video, we're going to look at the evolution of atomic theory. Before we start, you should have a general idea of the structure of an atom, so you may want to watch this video first. The ancient Greeks theorized that all matter can be divided into smaller and smaller units until such a point that there would only be tiny particles left that could not be divided any further. This was the first theory of the atom. Indeed, the word atom comes from the ancient Greek word atomos, which means indivisible. The next leap forward in our understanding of atoms came in the 1800s. A man called John Dalton concluded 5 main things from experiments he had been doing. 1. Atoms make up all matter. 2. Atoms cannot be subdivided into smaller particles. 3. Atoms of the same element are identical, whereas atoms of different elements differ. 4. Chemical reactions rearrange atoms in relation to each other, and compounds form when 2 or more different elements bond together. In the late 19th century, a man called Thomson expanded on Dalton's idea. He discovered the existence of electrons when making cathode ray beams interact with electric and magnetic fields. He determined that the cathode rays consisted of a beam of negatively charged particles that were 1800 times lighter than the lightest known atom, hydrogen. His discovery showed that atoms are made up of even smaller particles. He proposed the plum pudding model of the atom, whereby the atom is a positively charged sphere within which electrons swim. In the early 20th century, experiments designed by a man called Rutherford indicated that the plum pudding model was not entirely correct. 2 of his assistants called Geiger and Muller carried out the study. They used alpha particles, which are very tiny positively charged particles. They aimed a beam of alpha particles at very thin gold foil. If the alpha particles got through the foil, it would be detected by a sensor. Assuming Thomson's plum pudding model was correct, they expected all alpha particles would pass through the gold foil and be detected on the other side. However, while some did show this behavior, others emerged at unexpected angles, and some even deflected back to the alpha particle emitter, never passing through the foil. They concluded that the alpha particles were being repelled and deflected by the tiny concentrations of positively charged subatomic particles within the gold atoms which made up the gold foil. Since its discovery, atoms have been described as having a central nucleus of positive charge which is orbited by negatively charged electrons. This is known as the nuclear model of the atom. Bohr developed Rutherford's nuclear atom model further. He concluded from his own experiments that electrons occupy specific orbits or shells around the nucleus. In other words, electrons orbit the nucleus similar to how planets orbit the sun. However, electrons can only orbit at specific distances and within specific energies. So that's our current understanding of the atom. There is a positively charged nucleus with negatively charged electrons orbiting around it in specific shells.